Hello, reverse engineers. Let's welcome back with one more problem which looks impossible to solve at the first. Now, let's get into the position and let's attack this problem. So, whenever a network reduction problem or equivalent resistance problem comes, the first thing I advise you is to label it. Label basically represents the node potential. So always label in series. Like you start from here. So this circuit also, I'm going to label it in series. From here, I am going to label like this. So first was one, and this one stays correct till no other resistance comes there. So one potential here also. One resistance came, so two. Now here, I'll label it with a different color so that you get an. This is your one, two. Okay, this was your one, obviously. Then here you landed up with 3, 3. And see, the wire, the potential remains the same. The same wire is connected. Now 3. Now you notice these resistances, this 1 ohm, okay, and this 1 ohm, okay, is connected like this. But you'll say, sir, different label should be there. But what we are doing is, we are connecting it with a short circuit wire. So this short circuit, what it does is that it kills the resistance. If a resistance is across a short circuit wire, okay, so this short circuit, and how many ever resistances be there, 3 ohms, how many ever parallel resistance, that will kill it. So first thing, these two resistances, 1 ohm get killed. Now my new circuit is like this. Okay, now this gets killed, this gets replaced by a short circuit, and I'm left with 1 ohm, 1 ohm, 1 ohm. Okay, this is my new circuit here. So this is my 1 ohm, 1 ohm, and across this C. Basically, we are finding it across this, na, R equivalent across this. So now I have 1 ohm, 1 ohm, 1 ohm, and 1 ohm. So this 1 and 1 will become how much? So two resistances are in parallel. So this becomes zero point 0.5 ohms. And now I'm having 1 ohm and one more ohm over here. Okay. So this is the circuit. Across this, I have to find the R equivalent resistance. Now I notice, see, across this point it should have been, right? Because across the 2 point it is there, right? So across here, actually, you notice that 1 ohm, na, across these points I had to find. So across this I had to find. So this is my 1 ohm. 1 ohm, I realize there is a simple node over here. So this would become 1.5 in parallel with 1. Okay, 1.5 in parallel with 1. And now my R equivalent would be equal to, R equivalent would be equal to 1 in parallel with 1.5, which happens to be 1 into 1.5 divided by 2.5, that is 15 by 25, 5 threes are 5 fives are, that is zero point 0.6 ohms. So those of you who have enjoyed this and like the killer technique, kindly subscribe to our channel. Thanks.